Good morning, friends. This is Shivakkumar again. And so today, actually, we are going to see about, as a part of instrumentation engineering series, we are going to see the process control. So, what instrumentation engineers should know about the process controls, right? So, they should know about the process variable, degrees of freedom, first order, second order, third order freedoms, characteristics of liquid systems, gas systems, thermal systems, and mathematical model for the liquid process. Because when you are designing any even power plant or industrial instrumentation equipment design, you need to know about the gas system design, thermal system design, liquid system, liquid flow system, liquid level systems, how to maintain the temperature, how to prevent more damage of equipment due to temperature. So instrumentation will be a safety and safeguard futures for any industry, manufacturing industries or process industries, right? So even actually, in case of actually the chemical industries, you mean the equipment should not get eroded or corroded due to the acids or chemicals flowing through inside that. So we need to have a proper insulation and everything. So safeguard features to be followed, and also for efficiently monitoring and measuring the parameters, process parameters, we need efficient process control. And say I can say, we already see discussed about the computer process control, and this is a basic process control the instrumentation engineer should know. And after knowing that, actually they need to learn computer process control. So the computer process control will be an is a specialized or the second level approach in the process control, right? So first we need to know the basics of process control. So say they need to know the mathematical model, how to derive the particular process or design that, the liquid process controls and gas process controls, and thermal process, batch process, and continuous process controls, self regulations, everything they should understand on the process side. And that is what actually, if you know that process, then only you need to do the process control. So it's a result. So basic control actions, characteristics of on-off valves, proportional, and then single speed floaters and floating, integral and derivative control modes, composite control modes, P plus I, P plus D, and PAD control modes, and response of controllers for the different types of test inputs, pneumatic and electronic controllers to realize various control actions, and selection of control mode for different process, and then optimum controller settings, and tuning of controllers by process reaction curve methods, and continuous cycling methods, damping oscillation methods, Ziegler Nichols tuning, 1 by 4 decay ratios, and then feed forward control, ratio control, cascade control, averaging control, and then multivariable controls, and then I to P or P to I, right? Actually, so converters, pneumatic and electric actuators, and then wall positioners, and then control walls, characteristics of control walls, wall bodies, globe wall, butterfly wall, diaphragm, and ball valves, and control valve sizing, and then cavitation, flashing in control valve problems. So these are the control cavitation and flashing are the control valve problems. So how to avoid that, how to safeguard the valves during the operation of process parameters, process flows, and everything. And then actually we need to know about, the instrumentation engineer should, process control instrumentation engineer should know the distillation columns, control of top and bottom product compositions, and then reflex ratios, control of chemical reactors, and control of heat exchangers, steam boilers, drum level control and combustion control, and then piping and instrumentation diagram for control loops, right? And say if you want to know about the textbook, which textbook is good, then actually you need to know A. Polrod, Process Control, Eman educational books, and published in 1971, and D.P. Ekman, Automatic Process Control, Ville Eastern Limited, 1978. This is a very good book actually. DP Ekman book is very good for process control instrumentation. So getting the book is very difficult actually. We struggle a lot actually. And actually, during my engineering study, I have not seen this book, and only during the my power plant experience, and I got this book in the library. So it was brilliant to read and good. More interesting to read this topic, right? On process control by DP Ekman. Automatic process controls. Okay, this is a bible for the process control instrumentation. Okay, and then when talking about reference books, TB Weber, Introduction to Process Dynamics and Control, John Willey and Sons, 1973, and then P. Harrison, Process Control, Tata McGraw-Hill, 1984, and B.J. Liptak, Instrumentation in Process Industries, Volume 1 and 2, Chiltern Book Company, published 1974, and C. Stephanopoulos, Chemical Process Control, Prentice Hall Private Limited, 1990. This is a Bible for the chemical and instrumentation engineers on process-oriented sites. And then FG Shinsky Process Control System, third edition, McGraw-Hill Limited, 1990. 1990. So these process control actually plays a very important role in monitoring and measuring the process parameter, maintaining the process parameters, right? Actually, so this very good for the instrument engineer and a good selection. And actually, for those who are good in this process control will be paid more. We have very less people in this process control oriented field, and so you can choose as a good option for your career growth and shine in this career. Thanks, friends. This is GV Shivakkumar signing off.